Okay, welcome to the first Let's Code video. Today we're going to be talking about Racket. In this video we'll go over a few different things that Racket can do and just a little bit of its capabilities, some of the more strong points of Racket. One of the biggest things you might notice right off the bat is the paradigms that Racket falls under. Of course, it's multiple paradigm language. Functional is the one that we'll be focusing on today just because this is for the Functional Programming Club. And it is a Lisp dialect, so you'll see a lot of parentheses, and it's based on the scheme implementation, or it's inherited from scheme, not common Lisp. So one of the things that we can talk about in the background, I guess, just off the bat, is the Planet server, which is a package manager, or however you want to think of that, for Racket. It's really cool the way it manages stuff and the way it does different things and handles those things. Basically, like, it'll download something as soon as you require it if you don't have it downloaded automatically. Just considering you have permissions to do that. Today we're going to go over different data types, but this will be the most of them. We'll go over how to make functions, and we'll go over some different functions you may see commonly. We'll also go over like Boolean logic and stuff in Racket and a few of the operators you may want to use. Okay, so let's go ahead and dive into this, and we'll be using Dr. Racket for IDE today, and just so you can see how simple Racket is. First thing we'll do is we'll write hello world, and we can get the hello world string back. And that's it. 2 lines. You have to have this to indicate what language you're using. If you ever actually go into the language tab up here, you can see that there's a couple different ones that, Lazy Racket has the ability to use like lazy type evaluation, and there's basically just like other programming implementations, but they all run similar syntax. So what I show you here today won't be too far-fetched if you want to use one of these other dialects, because basically what they do is just change the system underneath it. And so let's go ahead and dive in. So we'll just show, like, the literals are pretty easy. They're what you expect. There's 2 ways to make a list. There's the easier way, which is to quote the list, which is the single quote, and then you can literally just call a function called list, and you get a list back. And yeah, okay, so characters are pretty simple as well. So run that, and we should get a bunch of stuff back. Yeah. So you see, like, it just printed stuff out like I typed it, and that's because those are literals. Another type of literal is what's called a symbol, and symbols are literally just symbols. Type whatever you want after the backtick, and it'll just treat it as data. And you can use these as like flags or something like that in your function. So like maybe you have like, well, if they pass this, you want that. Like this flag is set. The most important thing, I guess, to talk about today, since we are talking about functional languages, is how to make a function itself. And that's pretty simple. Define, name your function, so we'll call it our function. Well, let's code. And we can choose to give it many parameters. Give it author, language, and date. And then we'll have it just print out those things. And then we'll call it. So today is November Not that you would have known if I was lying about the date, but alright, so you see it gets those things. And well, okay, maybe you don't want that exact output, but one of the more annoying things is to try and get it just to not output the quotes. So sometimes you're just going to have to deal with that. There is a way to get rid of it, but we're not going to worry about that right now. Okay. So let's talk about Lambda functions, which are basically, well, they are anonymous functions. They look very similar. Basically, the only difference is you don't have a name now, and you swap out define for lambda, and we can call it xy, and we will take two things, and we'll add them together. So, and then we can define function, or we're just going to add. Give meaningful names when you define your functions. And go 1, 2. So now, this looks a lot like our earlier definition of a function, and this is something you would never really want to do, I guess. But what we've done is we've bound lambda, which returns a function, to a name, and so when you call the name, what happens is it returns the function, and then calls it with the parameters 1 and 2. So x gets bound to 1 gets bound to x, and y gets bound to 2. Yeah, or 2 gets bound to y. And then it calls the plus function. So if we call this, we should see 3. Okay, math hasn't broken. That's pretty good. Some more common things that you might see is you might see a function that looks kind of like this. So we'll call it sum, and then we'll give it a list. And we'll take our list, and we will see if the list is empty. Because if we have an empty list, then we don't need to do anything. So we'll just return 0. And if we don't, then what we'll do is call sum with car, which car will take the first element of the list, and then we will call plus car and list. And CDR, or coder, as some people pronounce it, is the tail of a list. Now, don't ask me why. There is probably a reason for why they're called car and coder. But the easiest way to remember it is A comes before D, and so if you want the first thing A, you want the rest of it D. So, just simple notation. Okay. Now, some things may look kind of weird about this function. Primarily the fact that, like, the if kind of just hangs out there, right? Because, like, well, okay, you said if empty and then return 0, but wasn't it just going to call this too? Well, the form of an if in Racket is not really the same as in languages, so it always has an else, in other words. Now you could make this something like false or undefined, which is a constant you can import, I think, and there's several other things that you can make it that basically just tell it like, hey, this broke. So like if this wasn't true, you messed up, and you can make it throw an error or an exception or whatever you want to do. But the form that we have this function in is what's known as tail recursion. So this is why it's called that. Tail recursion, you have a function A, and you have some base case, and then you may have some work in between, but normally you have like a call, recursive call to A, with obviously like different parameters, because you're in a circle if you don't, but this is called tail recursion. So that's tail recursion, and the reason that this is useful is because you can use something called tail recursion elimination or tail recursion optimization, which are actually the same thing, but there's two different words. So I don't know why people do that, but they do. Okay, so that's general form of tail recursion. You have your base case, which is 0 in this case, and then add the result, the first item of the list, with the result of calling the function. Sorry, forgot something. I think my prints were messing up earlier, and I can't figure out why. The result of calling the function on the end of the list. So let's go ahead and you really don't, like, it gets confusing to try and count parens. So if you notice, like, when you get to the end of a paren, it highlights everything that matches in the middle. So that's really useful. So that's why I'm using this IDE, because it kind of highlights. I don't know if you can see that or not. I'm assuming you can. Yeah, it looks like you can see it. Okay. So then we'll call our sum list. In just a second, I'll show you why this function can be replaced with a much shorter function. But this one can actually be replaced with multiply, add, and division, because this is sum from 1 to n, which is very easy to calculate. Okay, that's 10, which is what it should be. The other function that you might want to know about, which can do something similar, is called fold L. And we can take the same list and add it. Oh, sorry, I forgot a parameter. Never goes correct. Okay, see. So what this function does, go ahead and delete this one because we've just proven that it's sort of overkill. Fold L is of the following form. You have a function, we'll call that f, an accumulator, and your data, which is normally going to be a list. Technically it always has to be something that can be iterated over, which is, in this case, it's almost always going to be a list. There's another function that called fold R, and it takes a function, accumulator, and data. Okay, so what's the difference in these two functions? Well, as you may guess, they basically, one chooses to start from the left and one chooses to start from the right. So if we do fold R plus 0, 1, 2, 4, this won't make a difference, because the addition either way doesn't care which order you put the parameters in. In this case, and you actually could write, if you just wanted to really simplify things in this scenario, that. So these are prefix notation, which pretty much just means that the operators come first. And that's because, like I told you earlier, the syntax is very simple in most Lisp dialects. And so first thing is a function, and then you have your parameters. Now you can have functions like this as a function, as a parameter, but your first item after the opening paren, unless you're doing the literal, which is the backtick, or the quote, has to be a function. Type anything else in there, it's not going to be happy. We'll run this, and we should get 3 equivalent results. Now let's change this up. Okay. Now, what do you think is going to happen this time? You think we're going to get the same result? Well, it turns out in certain cases, this actually would be the same. I can show you one of those cases if you want me to, but they're kind of just like rare occurrences. But in this one, they're like having to be the exact opposite. But and we can change our accumulator and get different results. So for example, if we do like 1 and 1, okay. See, now they're not, so like that's not, it's not to say that like it's always going to be a mirror. It just happens to be mirrored in this case, where, you know, one's the opposite, the negative of the other. Okay, so why did this one turn out to be 8? So what happens here is 1 and then minus 2 is negative 1, and then minus 3 is negative 4, and then minus 4 is negative 8. Well, what if we wanted the same result? So, what if we do 1? We get the same result. Yeah. Okay, so that, in this case, is basically equivalent. As you can see, these two things are equivalent to this. So what happens here is 0 is always, or the accumulator is always the second argument passed in, and whatever it pulls from the list is the first argument. So 4 minus 0, which is still 4, then minus 3, or 3 minus 4, which is negative 1, and then 2 minus negative 1, which is 3, and then 1 minus 3. Now, if you didn't follow that, I'm going to explain in a little bit better syntax, a little bit more explicit syntax, I guess, what's happening here. Now, actually, notice that I could, because this last step is going to be basically just return the exact result that I typed in for the first parameter, I could cut that last one off, because what this is going to do is replace this with 4. So, technically speaking, like, this is pretty much just useless. And then it's going to subtract that. So this is equivalent to this, which is also equivalent to this. So that's 3 different forms of the same thing. Now what's fold left do? Well, if this takes it from the right side of the list and puts it in, left does the exact opposite. It takes the first parameter from the list, the car, and then puts it in that way. So you get the gist of it. Fold left and fold right. And what these are normally used for is like mapping something over a list or set of data. Very useful for a lot of different generic applications. And of course you can write lambdas in the middle of them that can do different stuff. Like if you want to get, like say you want to write really weird functions that, do something just, I don't know, to make something up. So you'll need 2 parameters, and let's, I'm going to word it. We'll say times x, y, and then I'm just making this up, by the way, so don't think that this makes any sense to anything. It's not like some secret formula or something. Okay, so let's see what happens. It's probably going to break because I probably messed something up here. Yeah, I think I did actually. Yeah, I did. Okay, there we go. Maybe that was wrong. No. Division by 0. Okay. That makes sense because you can't divide by 0. And that number's always going to be bigger. So what if we change these to now. Nope, still division by 0. Oh, okay, I know why. Accumulator is 0. That's one of the things. I'm going to see if it'll do automatic type conversion. It should. I was thinking it didn't the last time we were doing integer division. If it does integer division, we'll know immediately. Okay. Yeah. I love this about Racket. It gives these like really cool formats for outputting, and you don't have to do any work, which is really nice. So again, like that's just some random function that I wrote, but you see, you get the general gist of it. This can be anything, and then this is your accumulator, and this is your data. So, well, this can be anything in the sense that it can be any function. I should clarify that. Alright, so let's talk about some other stuff. I kind of skipped over it, and I should probably talk about like how plus and minus work, or the other operations, but I think I mentioned the infix notation. So basically just remember, first thing in the list is going to go first, and then it'll do what fold does, which is where it accumulates. So just remember that and you'll be fine. Some different Boolean tests you might want to know about. Equal. Just check to see if 2 things are equal. And and 4. So I mean, you could probably figured out that one, because you see that, you know, there's an and, so there's probably an or. You can do less than, greater than, all that. And I'm not going to write all these out, so I'm just, you're going to interpret that like some of this stuff exists because other things exist. So, alright, run that. We should get a bunch of booleans back. And shorthand booleans are basically just hashtag true, or pound symbol, pound symbol T, pound symbol F. Alright, now, what if we have a huge list and we want to check to see if like it's all positive? We can do that. And map positive. A lot of Boolean functions are written for you because, hey, that's something that we need. Actually, we'll do 1, 4. Okay. So obviously they're not. And then we can do the same thing. Ignore map. Now you remember the map from earlier, and you're probably gonna get the exact. You're gonna know what this does. I would almost guarantee you before it ever, tells you. So basically, what it's gonna do is it's gonna map that positive function across, and then it's gonna and them together. So that's fine. Don't care what that is. And run that. Oh wait. Oh, misspelled positive. If you misspell the function, it will not tell you what you were trying to do. Okay. And that's what we expected. And of course, if we want, want them to both be true, because true is good. You always want to see true stuff, unless it's negative stuff. But just always write your test so that it's true, it's positive. Okay. So, what else can we talk about? One last thing I'd like to talk about. Actually, two things. First is let. Now, let has kind of a weird syntax, but if you just follow with me, it's not that bad. So let's say we have a function, fine, function, and maybe for some reason, I don't know, we have something that we do with that data A, and we're going to use that later, and we just don't want to have to keep calling the values over and over and over again, because we're going to have to call these functions. Now if these are just literals, you can still use let, but magic numbers are bad, so don't use magic numbers, I guess, but don't just have unnamed variables in your function and you're like, hey, what does that do? And you're like, I don't know. But what you want to do, if you can, is use let, which there shouldn't be a problem for that. And let is going to be local scope, so it'll shadow values that are the same thing, just many other languages do. It kind of has this weird syntax. So let's just say that we want the car of A, which, like I said earlier, is the first element, and we'll say the second element of A. So there's some shorthands written there, just so you know. Now anything inside of that parentheses is going to have A. So what we'll do here is, let's say that we want to add, or we want to, I don't know, square A, the first element of A, and then divide that by the square of Y. Well, maybe you're, doing some geometry or something, you've got maps or points or whatever. I don't know. But we can now call our function, and I wanted to show you this just so you know. Okay, so that's the same return type as lambda x or whatever. Notice I didn't use those parameters. That was kind of dumb, but it's the same thing. The only difference is that the colon at the end tells you that it's defined as a named function instead of just a random procedure. Okay, so now let's actually call our function. We'll give it a list. We'll say, I don't know. Maybe we've got a triangle and we're trying to calculate, what the other side is or something. No, that wouldn't be. I don't know. Either way. Yeah, that'll work. Yeah, that would be true. Never mind. So we've got a hypotenuse of 5, and then one of the legs is 4. Call our function. That's not right. Oh, it would be minus. Yeah, that's right. I'm bad at math today. But you see again, we got our input back. And what is weird is that, like in this case, we can do like whatever we want here. It doesn't actually matter, and we'll still get the same thing back because it just ignores those parameters. And list is a good way to like have multiple parameters of an unknown value. I think there's a way you can actually do that where you have like more or like it's basically like it binds the rest of the variables to a list for you instead of you have to explicitly name them. So that's it for this talk. We'll probably do another talk later. Oh, one last thing. I just keep forgetting stuff. One last thing I wanted to show you guys was one of the really cool libraries that I like, which is the number theory library. If you don't like discrete math and you're in computer science, then I'm sorry. But that's going to be false, but let's do this. This is a Project Euler challenge, so here's an answer if you do Project Euler challenges, which are math challenges. So that's false, but the cool thing is that we can do like, we'll do some like really ridiculously large number. It'll probably take it a minute. Maybe not that big. There we go. Yeah, we can do that. I think it's going to handle that. Shouldn't take it incredibly long amount of time. But, of course, like primality is one of those things that's really cool and hard to test, and like, there are some efficient algorithms for doing this, but there's no algorithm that's like able to compute large primes, because that's, of course, like very key in security and stuff like that if you've ever basically worked with anything in security. Now, one last thing, I swear that's the last time I'm going to say that, is the website for Racket-lang, or racket-lang.org, which is, yeah, I just pulled up the syntax for let, so, okay, there it goes. A little bit slow today for some reason. Oh, probably because that's working in the background. They've got these little quick examples up front, and they can do some really neat stuff. So like, one of the like cool things is that it has this library that deals with images. So like if we let's do stop. If you ever need to kill a function that's running forever, we'll just really quickly and of course like all the examples on this are pretty small. And condition is just another way to do ifs. It allows for multiple statements. And there's also a thing called match, which has a similar syntax to this. In fact, I think match is the exact same as this, except for it adds in like a value right here, and then it matches against that value. Way stronger than switch statements, just so you know. And see here we're using the symbols, which I had mentioned earlier. It's a really good example. And then else is basically like default true. And one of the really cool things about this website is it's got a ton of documentation, and the community is really helpful. And they've set this language up so that you really don't have to worry about much. Wait a minute. Oh, I misspelled that. Yeah. Okay. Yeah, and we get this really cool image. You probably won't see too many C++ tutorials that are that short that draw stuff like this. Maybe in Java. Probably still not that short. Anyways, that's it. Hope you enjoyed the tutorial. We'll be doing another video soon, most likely on Scala or Erlang or Elixir. If you guys want to, in the comments section below, just vote which one of those you want to do. Thank you for your time. Y'all have a good day.